This is Module 5, Lesson 10. In this lesson, we'll be using an area model and division to show equivalence of two fractions. We're going to start with an area model that's going to show the fraction 10/12. So we'll start by dividing the whole into 12 units. So the total number of units we have is 12. And we're going to shade 10 of them. So we're going to select them by shading. So we've selected or shaded 10 units. Now we're going to compose to make an equivalent fraction. When we compose, we are combining smaller units into larger ones. So we need to find a way to combine the total number of units, which is 12, into larger units and combine the numerator, which is the number of selected units, also the same way. So whatever we do in terms of combining the total units, we have to be able to do the same kind of combinations to our selected units. So to do that, we look for a number that will evenly divide both the numerator and the denominator. So we see that both 10 and 12 are even numbers. So we know right away from our study of factors that if a number is even, meaning that there's 0, 2, 4, 6, or 8 in the ones place, we can divide by 2. So let's do that. Let's divide both the numerator and the denominator by 2. And 10 divided by 2 is 5, and 12 divided by 2 is 6. So what we're doing here is we're taking the total 12 units and we're grouping them into groups of 2. So let's do that on our area model. There's 2, there's 2, there's 2, and 2, and 2, and 2. So we've put 2 of these smaller units together to make equal size larger units. And if we count 1, 2, 3, 4, 5, 6, we see that's what we have here. We've taken the total number of units and divided it into groups of 2, so that gives us 6 groups of 2. Then if we look at the numerator, and we originally had 10 units shaded, now we're going to combine them also into groups of 2. So let's do it this way so we can see the difference. There's 2, 2 more, 2 more, 2 more, and 2 more. So we've also grouped the 10 shaded units into groups of 2, and we see that we do have 1, 2, 3, 4, 5. So we can see from our area model that whether we shade 10/12 or whether we shade 5/6, we have an equivalent amount of space in the area model that's shaded in. So we can say that 10/12 and 5/6 are equivalent fractions. Now, to help us find this number of what we can divide them by, we can list all the factors of the numerator and all the factors of the denominator. Remember, factors are the pairs of numbers when multiplied together give us this product. So we always can do 1 and the number itself. Those are always factors. We can do 2 times 5. 3 doesn't work, 4 doesn't work, 5 doesn't work. 5 we have, 6 doesn't work. So those are the factors for 10. For 12, we have 1 and 12. We have 2 and 6, and 3 times 4. So those are all the factors for 12. So every factor has 1, and dividing by 1 doesn't do us any good because we end up with the same number. So we forget about the ones that are common. And then we look at, given the factors that are left, which ones are common or are listed in both sets of factors. So we see we have 2 here and we have 2. 5 is only on 1, 3, 4, 6, 12, and 10 are only on one factor, one product. So the only common factor, common meaning they're on both lists. So the common factor for 10 and 12 is 2. So that's the number we're going to divide by. We're going to divide by the common factor. Because if the number is a factor of the total that we're looking for, then we can also divide that number evenly by that factor. Okay, let's look at another one. Let's start with 6/10ths, I'm sorry. And again, we're going to look for a number that we can divide both 6 and 10 by. And again, right away we see that since both numbers are even, we know we can divide by 2. So if we divide 6 divided by 2 is 3, and 10 divided by 2 is 5. Then we look at this new fraction that we have and ask ourselves, are there any other common factors between 3 and 5 where we could combine again to make an even larger unit? Well, the factors of 3 are 1 and 3, and the factors of 5 are 1 and 5. Because both 3 and 5 are prime, we know that means their only factors are 1 in itself. So there are no common factors. So when there's no common factors, we know that these units are as large as they can be. There's nothing else we can divide by. And we call this resulting fraction, we say that it's in simplest form, which means we're showing as large units as possible. We can't combine in any way other than 3/5. But 6/10ths then and 3/5 are both equivalent fraction. And we call this process of getting simplest form simplifying. So we're simplifying the fraction 6/10ths into 3/5 by dividing by 2. Let's look at another one. Let's do an area model. Again, that's going to show 12 originally. We're going to divide this rectangle, our area model, into 12 pieces. So we'll divide 6 columns and 2 rows. So we have 12ths as our total number of units that the whole is divided into. We're going to shade 8 of them. So we're going to select them by shading. So our numerator is 8 to indicate the number of fractional units that we're selecting. Now we're going to see what we can do to simplify this fraction. So we look at 8 and 12, and again we see 2 numbers that are both even, so we know we can divide by 2. So let's do that. 8 divided by 2 is 4, and 12 divided by 2 is 6. So let's do that on our area model. So we're taking our 12 original units and we're grouping them into groups of 2. So we have 6 groups, and then we're taking our numerator of 8 units and putting them in groups of 2. We end up with 4, 1, 2, 3, 4. So we have 4, 6. But 4 and 6 are also even numbers. So that tells us we can divide again by 2. 4 divided by 2 is 2, And 6 divided by 2 is 3. So we're going to take these that we've done here and we're going to collapse them again. So we have 2 units here and we can collapse them into a group of 2. These 2 larger units, combining them again, composing them again into a group of 2. And finally these 2. So our denominator is 3 now. We have 3 overall units, of which 2 are shaded. Now, if we look at the factors of 2, we have 1 and 2, and we only have 1 and 3. So we now know that this is in simplest form because there's no other number that we can divide both 2 and 3 by evenly. So that's simplest form. Now let's look at what we did here. First we divided by 2, and then we divided by 2 again. So instead of doing that as 2 steps, we could have initially divided both the numerator and the denominator by 4, since 4 is a factor of both 8 and 12, and we get directly to 2/3. So these are all equivalent fractions, 8/12, 4/6, and 2/3. But if our goal is to get simplest form, then we want to look for the greatest common factor between the numerator and the denominator to get directly to simplest form. Let's look at one more. So let's go back to the one we were just looking at, 8/12, and let's list all the factors. So 8 and 1, then we have 2 and 4, 3, 5, 6, 7. Those are not factors. So these are our factors of 8. Then look our factors of 12. We have 1 and 12, 2 and 6, and 3 and 4. And then let's circle the factors that are common to both numbers. Well, we have 2 and we have 4. So 2 and 4 are common factors. So we could divide 8 and 12 by both 2 and 4, but 4 is the greatest common factor. So again, if our goal is to get to the simplest form as quickly as possible, we want to divide by the greatest common factor. So if we divide 8 divided by 4 and 12 divided by 4, we get 2/3. And again, as we saw in the last problem, there's no common factors for 2 or 3 other than 1. So 2/3 is in simplest form. So we can still get to simplest form by dividing by 2 and then dividing by 2 again. It's just that it takes us 2 steps instead of 1. So the most efficient way is to divide by the greatest common factor right from the beginning. Okay, let's use this to solve some problems in our problem set. So we know from the beginning that each rectangle represents 1. So our directions say to compose, so we're putting together, we're creating larger units. So we're composing the shaded fraction into larger fractional units. Express the equivalent fractions in a number sentence using division. The first one's been done. So in our original model, there were 6 total units. 4 of them were shaded. Each of the numerator and the denominator divided by 2, and we ended up with 2/3. And then if we show that, we have 3 total units now, and 2 of them are shaded. Okay, pause the video and try B. Okay, for B, we see that we have 3 rows of 4, 3 times 4, so we start with 12 total units. We've selected 9 of them by shading, so we have 9/12. So if we go through the factors of both 9 and 12, we see that the common factor for 9 and 12 is 3. If we divide, we see 9 divided by 3 is 3, and 12 divided by 3 is 4. And the factors of 3 are 1 and 3. The factors of 4 are 1, 2, and 4. So there's no common factor. So we're in simplest form. Showing this on the area model, we grouped 3 of the original units together to create our larger units. We created groups of 3. So we created 4 groups of 3, and 3 of them are shaded, which becomes our numerator. Okay, pause the video and try C. Okay, for C, we started out with 10 total units. 6 of them were shaded. We see these numbers are both even, so we know we can divide by 2. And we get 3/5. And we look at the factors of 3 and 5 and see they're both prime numbers, so there's no common factors. And showing it on our area model, we grouped 2 of the smaller units together into larger units. So we have 5 total units, of which 3 are shaded, as shown by this fraction. Okay, try D. Here we started with 8 units, so we show that in our denominator. 6 of those are shaded, which becomes our numerator. To simplify this, both 6 and 8 are even numbers, so we can divide by 2. And we get 3/4. And there's no common factors between 3 and 4, so we know we're in simplest form. We grouped 2 together in composing this fraction. So we see we have 4 total units and 3 are shaded. Okay. Moving on to number 2. It says compose the shaded units into larger units. Express the equivalent fractions in a number sentence using division. Pause the video and try A. So for A, we have 4, 6 shaded. Looking for a common factor, we see that 2 is a common factor of both 2 and 6. When we divide, we get 2/3. So grouping these into groups of 2 now, we have 1, 2, 3 total units, of which 2 are shaded. Pause the video and try B. So for B, we have 12 total units. 8 of them are shaded. So we want to simplify this. Now you can divide by 2 here. It doesn't say we need simplest form, so that's one possibility. But from our previous lesson, we remember that 8 and 12 both have factors of 4. So we could divide by 4 and get 2/3. And 2/3 is in simplest form, showing that here we're composing the smaller units into groups of 4, shown by our division, and we end up with 3 total units, of which 2 are shaded. For number 3, it says to draw an area model to represent each number sentence below. So pause the video and try A. For A, our total number of units to start with is 10. So we're going to show our area model with 5 columns and 2 rows, total of 10. And 4 of them are selected, as shown by our numerator. And then our division tells us we're grouping 2 of the smaller units into larger units. So we end up with 5 total units, and 2 of them are shaded. So we have represented the number sentence. Try B. So for B, we're starting out with ninths. So let's draw 3 columns and 3 rows for a total of 9 units. 6 of them are shaded. Our number sentences tells us we're grouping them into groups of 3. So we have 1, 2, 3, for a total of 3 total units, of which 2 are shaded. So we've demonstrated the number sentence. For number 4, it says use division to rename each fraction given below. Draw a model if that helps you. See if you can use the largest common factor. So you don't have to draw a model here, but you're welcome to do that if it helps you visualize it. So pause the video and try A. Okay, for A, it's telling us if we can to use the largest common factor. So the factors of 4 are 1, 2, and 4. And the factors of 8 are 1, 2, 4, and 8. So I see 2 is a common factor and 4 is a common factor, but 4 is the largest common factor. So I'm going to divide by 4. And I get 4 divided by 4 is 1 and 8 divided by 4 is 2. So I get 1/2. And unit fractions are always in simplest form because 1 only has 1 as a factor. Pause the video and try B. So again, for 12 and 16, they both have 4 as a factor. So we can divide both 12 by 4 and 16 by 4. And we end up with 3/4. And again, there's no common factors, so that's as simplest form as we can find for an equivalence of 12/16. Try C. For 12 and 20, again, the numbers are even, so we know we could divide by 2. Let's see if we could divide by 4. Yes, 4 times 3 is 12, and 5 times 4 is 12, so we know we can divide both of the numbers by 4. And we get 3/5, which are both prime, so we know it's in simplest form. And pause the video and try D. 16/20. So we can use, again, 4 as a common factor. And we end up with 4/5. 5 is a prime number. So unless 5 is a factor of 4, which it's not, this number is in simplest form. And that concludes lesson 10.